Imagine if your thoughts, your body, the stars above, and the very void between them were nothing more than a quick sketch on a cosmic canvas, liable to be erased at any moment. How would you perceive reality? What if the vast and ancient world we inhabit is actually suspended by a thin tin wire that could snap without warning? In the realm of quantum mechanics, this isn't mere fantasy. We might be living in a false vacuum, a state of extreme fragility that could collapse at any time. A single, minuscule quantum fluctuation could trigger a catastrophic transformation, unfolding at the speed of light and rewriting the very fabric of existence. There would be no explosion, no sound, only an instantaneous transition. Atoms would dissolve, space-time would unravel, and everything we recognize would vanish into silence. You wouldn't feel it, you wouldn't see it, it would simply happen. This isn't science fiction, it is a genuine physical possibility known as quantum tunneling. On a long enough time scale, even the impossible becomes inevitable. Today, we dive deep into the mysteries of vacuum decay. What role does the Higgs field play? What is the ultimate fate of the multiverse? And if reality can disappear in an instant, how do we understand existence itself? This is a descent into the deepest unknowns of science, a journey that may overturn everything you thought you knew. It's a long story, but before we dream our way through it, please remember to like, share, and follow. Imagine waking up on an ordinary morning. Sunlight streams through the window, the sky is as blue as ever, and life proceeds as usual. But in a distant corner of the cosmos, reality begins to disintegrate. A silent, unstoppable ripple spreads quietly, leaving no warning, no sound, and no trace. This isn't a movie plot, it is a serious physical hypothesis called false vacuum theory. It suggests that while our universe appears stable, it hides a fragile lie. From Einstein's elegant equations to the bizarre laws of quantum mechanics, all our physical theories are built on assumptions we have never truly verified. We take for granted that space and time will maintain their laws, and that particles will behave tomorrow as they do today. But what if the foundation of reality suddenly shifts? What if all of this is just a temporary illusion? In the silence of deep space, quantum fields vibrate with hidden potential. Invisible particles flicker in and out of existence, perhaps hinting at a deeper chaos beneath the surface order. Black holes leak information like slow drips of rain, carrying secrets we have yet to decode, secrets that might one day break through the boundaries and rewrite the structure of the entire universe. There is only a thin line between what we know and what we think we know, and that line is starting to crack. The James Webb Space Telescope has taken us further into the past than ever before, revealing galaxies that theoretically shouldn't exist, challenging our established cosmological models. Quantum computers perform trillions of operations per second, yet often yield answers that classical logic cannot explain. Are we glimpsing a deeper structure of reality, or is the structure itself failing? The universe owes us no explanation and never promised to follow our theories. If the loom of space-time is woven not from strings or particles, but from consciousness, entropy, or information, then pulling a single wrong thread could unravel everything. This is where we stand, at the frontier of physics and at the edge where reality itself may no longer be stable. Every scientific breakthrough peels back a layer of the veil, but what if the next layer reveals not an answer, but a collapse? The cosmic cliff before us isn't just a theoretical construct, it is a real possibility that even the greatest minds hesitate to speak aloud, that reality might not just be misunderstood, but could be on the verge of breaking down. If that moment comes, in that silent void, we will have no way of knowing what awaits us. When we hear the word vacuum, most people think of nothingness, a space devoid of matter, a silence where nothing happens. But in quantum physics, a vacuum is far from empty. It is teeming with invisible energy, virtual particles interacting for fractions of a second, and omnipresent potential. Even in the darkest regions between galaxies, space is never truly quiet, it fluctuates and seethes with unseen motion. This reality is stranger and more dangerous than anything we once imagined. To understand this, we must enter the world of quantum fields. These aren't abstract concepts, they are the fundamental bedrock of the universe. Everything electrons, photons, quarks is not stuff in the traditional sense, but temporary ripples in underlying fields that fill all of space. Think of it as a calm ocean, a single wave is a particle, and the ocean itself is the field. Every type of particle has its own field. An electron isn't a tiny speck flying through space, it is a disturbance in the electron field. A photon is a ripple in the electromagnetic field. Even the famous Higgs boson is just a brief excitation in the Higgs field, which grants mass to other particles. A vacuum, then, is simply the state of space when all these fields are at their lowest possible energy levels, with no particles being excited. Yet, it isn't peaceful, it's a boiling, shimmering foam of possibility. This is where things get unsettling. Physicists suspect that the vacuum we inhabit, the background of our entire universe, might not be the true vacuum. We might be in a false vacuum. This technical term carries a deadly meaning. Our current state is metastable. Like a pencil balanced on its tip, it is temporarily stable but will fall if nudged. This state could last for billions of years, or it could collapse in the next second. This idea stems from quantum field theory, which suggests fields can have multiple configurations, each corresponding to different energy states. Imagine a mountain range with many valleys of varying depths. Our universe might be sitting in a shallow valley, a local minimum. But beyond an energy barrier we cannot yet cross, there might be a deeper valley, a true vacuum with a lower, more fundamental energy state. If our universe tunnels into that deeper valley, vacuum decay occurs, and everything is rewritten. A bubble of true vacuum would be born and expand at the speed of light. Inside this bubble, the physics we know would cease to exist. Constants would change, fundamental forces would warp, and even atoms might fail to form. Existence wouldn't be blown up, it would be deleted by a change in logical structure. The mathematics of quantum field theory allows for this, and research into the Higgs boson suggests we may indeed be in this precarious state. The Higgs mass is approximately 125 gigaelectronvolts, a value that sits right on the edge of the threshold predicted for a false vacuum. It's as if nature is whispering that we aren't supposed to be here. Currently, we are kept safe by the massive amount of energy required to jump from the false vacuum to the true one. On a cosmic scale, quantum tunneling is extremely rare, but it is not impossible. A random fluctuation, a slight quantum shift, or a high-energy event like a cosmic ray impact or a powerful particle collider experiment could theoretically trigger the end. This fragile balance isn't a metaphor, it is a precise description of our cosmic reality. Every second of our existence depends on this false stability, and the ground beneath us could shift at any moment. Intriguingly, this fragile vacuum structure might have existed since the dawn of time. After the Big Bang, the universe underwent a period of incredibly rapid expansion known as inflation, likely driven by a high-energy vacuum state. When that state decayed, it released the colossal energy that formed all the matter, stars, and galaxies we see today. In a sense, vacuum decay created everything, but it also has the power to end everything. Some physicists suggest that certain regions of the cosmos may have already transitioned into a deeper vacuum, forming bubble universes with entirely different physical laws, isolated and alien to us. One of these bubbles could be heading toward us right now, and we would never know until the moment it arrives and overwrites our reality. The vacuum is not empty, it is a structured mechanism of rules and forces, but it is not permanent. We are like residents on a thin cosmic membrane, floating in tension, with no idea how thin that membrane is or how long it can hold. One fluctuation is all it takes. If that change ever comes, there will be no preview, no alarm, and no escape. There would only be the silent birth of a new universe and the abrupt disappearance of our own. This thought is deeply haunting. The universe could be erased without warning, with no countdown, no final goodbyes, and no time to comprehend the end. This is a real possibility written into the equations of quantum field theory. Behind this unimaginable catastrophe is a process called vacuum decay, triggered by a tiny, destructive bubble. If it forms, it will be the last thing the universe ever knows. To understand how this bubble ends everything, we return to the ball in a valley analogy. Our universe is the ball in a shallow pit on a mountainside. It looks stable, but if there's a deeper pit nearby, it could roll over. In quantum mechanics, systems aren't strictly trapped by energy barriers. Through quantum tunneling, a field can ignore the barrier and instantaneously jump to a lower state. Once this happens, the decay begins. A subatomic bubble of true vacuum appears, its edge acting as a transition zone. Inside, the laws of nature are rewritten. Protons, neutrons, and electrons might become unstable or vanish entirely. Chemistry would end, life would be impossible, and matter itself would dissolve. This isn't a fiery explosion, it's more terrifying. The bubble expands at the speed of light, meaning no warning could ever reach you. The moment the light of the event hits your eyes, you have already ceased to exist. It would sweep through galaxies, devouring stars and space-time itself, not just destroying the universe but replacing it with something else. This isn't just a wild theory, it's a deduction from our most precise models. After the 2012 discovery of the Higgs boson, its mass was measured at roughly 125 gigaelectronvolts. This specific number is a warning sign. According to our current models, this value puts us right on the critical edge of a false vacuum. We are standing on a ledge. What stops the decay is the sheer energy barrier between states, making the probability of tunneling incredibly low but never zero. Every experiment we run and every breath we take relies on this temporary, unstable cosmic scaffolding. The Higgs field doesn't just explain why things have mass, it reveals that reality is a gift, not a guarantee. If the Higgs boson were slightly heavier, perhaps 130 gigaelectronvolts, our universe might be in a truly stable vacuum. If it were lighter, the universe might have collapsed before it even began. We exist in this narrow window between extremes. Is this balance a mere coincidence, or evidence of a multiverse? In some string theory models, different regions of space can fall into different vacuum states, each creating a bubble universe with its own constants. From this perspective, our universe is just one of many a world that happened to fall into a metastable but long-lived state. Other bubbles may be more stable, or may have long since vanished. Our very existence might depend on this instability. The Higgs field gave us mass and structure, but it also placed us at the edge of a quantum abyss. Everything we know, time, space, and physics itself, is built on a temporary frame that won't fall because of a mistake, but because that is simply how quantum reality operates. This leaves us with the most profound question of all: how much longer can reality last? In the classical world, everything is deterministic. A ball rolls down a slope, a glass shatters upon hitting the ground, and an object remains at rest unless acted upon. But in the microscopic realm, the quantum domain, the certainty vanishes. Welcome to the quantum world, where particles can pass through walls and probability reigns supreme. Here, the laws of physics are not clear-cut textbook equations, they are more like a game of dice. Within this strange system exists a phenomenon that feels like magic: quantum tunneling. Imagine a particle trapped inside a closed box with high walls. It lacks the energy to climb out. In classical physics, it remains trapped forever. But in quantum physics, there is a statistical chance the particle will suddenly appear on the other side of the barrier, as if it took a shortcut through reality. It didn't climb over, and it didn't dig a hole, it simply existed there by way of probability. This is a glitch in reality. Quantum tunneling is not a fantasy, it is a verified phenomenon that powers the nuclear fusion. In our Sun, the operation of modern electronics, and the process of radioactive decay. At the quantum level, even a vacuum is never truly still, it fluctuates like a restless sea. Particles are no longer fixed points but wave functions representing the probability of where they might appear. This means a particle can partially exist outside of its allowed zone, eventually manifesting there. Now, extend this concept to the entire universe. Our cosmos might be like a particle trapped in a shallow pit, seemingly stable, but not at its lowest energy state. Quantum mechanics tells us that given enough time, even without the energy to jump out, it could tunnel into a different state. This is the basis of vacuum decay. It requires no external trigger, only time. Every second of existence is a roll of the cosmic dice, and if you roll them enough times, eventually the worst outcome occurs. This isn't speculation, it is an inherent prediction of the mathematical models in quantum field theory. Any point in space could become the starting point for such an event. Once it begins, a bubble of true vacuum would expand at the speed of light, rewriting the laws of physics in its wake. Nothing can stop it, and no observer could see it coming, because the moment the signal reaches you, you cease to exist. We cannot predict the time or location, but the probability persists over the long term. It suggests our universe is not an eternal home, but a temporary structure that could be redefined at any moment. The longer time passes, the higher the risk. We are playing a cosmic version of Russian roulette with an infinite number of chambers, and the fact that we still exist is not a right granted by the universe, but a stroke of sheer luck. The universe owes us nothing, we are here today simply because the dice have not yet landed on the final side. If quantum tunneling can destroy our universe, could it threaten others as well? What if this is just the first domino to fall? This isn't just a plot for a comic book, it is a deduction from theoretical physics suggesting the entire multiverse might be equally fragile. To understand this, we must look far beyond the observable horizon. Multiverse theory proposes that our universe is just one of many, each with its own physical constants and vacuum states. Some might be similar to ours, others might have different dimensions or forces entirely. Whether these universes float like bubbles in an inflationary sea or are separated by higher dimensions, the terrifying question remains: what happens if one of them suffers vacuum decay? Quantum field theory suggests a vacuum collapse could potentially cross the boundaries between universes. In a multiverse governed by a unified energy field, one universe falling into a deeper valley could trigger a chain reaction, a cosmic domino effect. If the field itself undergoes a phase transition, or if one bubble decays violently enough, the resulting shock wave could spill over into neighboring bubbles. Some theories even suggest that universes might be quantumly entangled from birth, meaning a drastic change in one could resonate through others. While speculative, this presents a disturbing vision. The entire system of reality might be more interdependent and vulnerable than we imagined. If a vacuum bubble from a distant, hidden universe expands and hits our boundary, would it stop, or would it simply crush us? If it continues, the entire multiverse could collapse in a silent reset, replaced by a new reality we can neither imagine nor perceive. While we have no proof of other universes yet, our models suggest that if they exist and share an energy field, instability is a universal threat. The cosmos might be a house of cards exquisite in design, but fundamentally fragile, where a single quantum mutation could silence the story of existence forever. Imagine the moment the universe decides to delete itself. No sound, no light, no warning, just an instantaneous rewrite of reality. This is the horror of vacuum decay, a silent, total end. Yet, for scientists, this silence is a challenge. Can we detect the warning signs? To detect vacuum decay, we must perceive the rules of reality changing. We cannot watch it approach like an asteroid because it travels at light speed and originates from quantum tunneling. However, some theories suggest that if the universe is nearing a transition, we might see subtle anomalies in physical constants, like a slight shift in the strength of electromagnetism or the fine structure constant. Physicists use incredibly sensitive instruments, like atomic interferometers and particle detectors, to search for these billionth degree deviations. But even if we find them, the transition itself is like a light switch, instantaneous. If a bubble forms across the galaxy, we vanish before the information reaches us. Despite this, experimental physics continues to push boundaries. At the Large Hadron Collider, scientists study the Higgs field to understand the mechanisms of vacuum stability. The 2012 discovery of the Higgs boson showed its mass sits in a precarious metastable region. By mapping the vacuum stability phase diagram, we try to calculate our odds. But detection does not mean prevention. There is no fleeing from a light-speed bubble that rewrites the very logic of atoms. Some wonder if a future civilization could reinforce the false vacuum, or if we live in a simulation where such an event is a system reboot. These ideas highlight our drive to understand even the most helpless scenarios. We search for the truth not because we can change the outcome, but because the quest itself gives meaning to our existence. The journey to these conclusions began not with a bang, but with a whisper, an anomaly in how light behaved that baffled scientists in the early 20th century. When classical physics failed to explain black-body radiation, Niels Bohr and others proposed a revolutionary idea: reality is discrete and probabilistic, not continuous and certain. This turned the scientific world upside down. Einstein famously resisted this chaos, claiming God does not play dice, to which Bohr replied, "Stop telling God what to do." This debate shaped the last century of physics, leading to the uncertainty principle, wave equations, and quantum field theory. We realized that particles are waves, reality is a superposition of states, and observation changes the outcome. By the mid-20th century, the quantum zoo grew to include quarks, neutrinos, and bosons, eventually forming the Standard Model. This model explained almost everything but had one missing piece: the Higgs boson. Without it, the whole framework would fail. This led to the construction of the Large Hadron Collider, a 17-mile tunnel where protons collide at near light speeds. In 2012, the world watched as scientists announced they had finally found the Higgs It was a triumph, but one that came with a warning. The Higgs mass suggests we are on the edge of a quantum abyss. Our scientific journey has shifted from discovery to a sense of profound unease. We once thought we could master the quantum world, but we now realize its rules might eventually erase us. Yet, the search continues. We upgrade our colliders and refine our equations, looking for supersymmetry or dark matter, trying to see if our place in the cosmos is truly secure. This exploration is about more than particles, it is a journey for meaning. We stand at the edge of the unknown, facing the beautiful and terrifying truth that reality is not nearly as solid as it seems. We push forward through equations and paradoxes, building massive machines to see what lies behind the veil of uncertainty. That is all for today's sharing. I hope you have a beautiful dream. See you next time.